Okay, I hope we are live. As always, please write something in the YouTube so we know that we are heard and we are seen. And today we have a new, we have a number of visitors already. So I hope they see us and they hear us. Please write something in the chat. I'm in the YouTube chat. So today we have a new Kotlin Moscow meetup in English this time. So you have to learn English as well. And today our guest is Alexey Soshin, solution architect at Depop, and he will tell us about Ktor plugins development. I think it's a very interesting topic. And as we are Kotlin Moscow, you can ask your questions in Russian, both in YouTube and in Telegram, and I will translate them. But generally, the talk is in English. I forgot to introduce myself. My name is Alexander Nozick still. I'm still the same. So, Alexey, please continue.
Thank you very much for the introduction, Alexander. So today, as Alexander already said, we are going to talk about writing our own plugin in Ktor Web Framework. But before we do that, let me briefly tell you about myself and about my role at Depop. So I'm a solution architect at Depop. I live and work in London. And Depop is a marketplace for fashion. So we have 25 million users globally. We have 30 million active items and more than 100,000 items added every day. In terms of engineering, we are about 100 engineers at the moment, and we have around 200 microservices, which are currently mostly written in Scala. So for the past half year, we were evaluating adding Kotlin to our tech stack. There are a number of reasons for that. First, Kotlin is easier to learn than Scala, especially for developers that aren't coming from functional background. It's familiar to both Java developers and Android developers, which was a big benefit for us. Second reason is that we are using Play framework for Scala, and it's not the fastest framework. It's not well suited for something like proxying lots of API calls, for example. So at Depop, we adopted backend for frontend architecture. For those that aren't familiar with that kind of architecture, the idea is that each domain has a service that formats the responses in a way which works best for the mobile and web clients. We have around 40 microservices in the backend for frontend layer. Those are services that mostly proxy calls to other services and compose JSONs. Play framework, though, struggles with such work. We could rewrite our BFF layer using another Scala framework, but we decided to try Kotlin and Ktor instead. We chose Ktor because it's idiomatic, productive, and performant enough for us. One of our main requirements from those new Kotlin services was that they would report the same metrics as the Scala ones. At Depop, we have a lot of tooling built around our monitoring, like auto-generated Datadog dashboards, and ideally, we wanted to reuse all of it. So the real struggle wasn't really Kotlin versus Scala, but more how are we going to integrate our Kotlin microservices with Datadog the same way Scala does. So let's talk a little bit about cross-cutting concerns. Monitoring is just one of them, and any web framework such as Ktor, needs to address some of them. There is logging, templating, handling different headers, authentication, content negotiation, and so on. So that's something that we need to handle for all of our requests or most of our requests. Different frameworks have different approaches for handling cross-cutting concerns. So Spring Boot, for example, uses annotations. Vertex uses generic handlers, which is a chain of filters. And in Ktor, there is a plugin mechanism instead. So Ktor has built-in solution for almost any of the cross-cutting concerns at the moment. There are plugins for monitoring, for logging, for different template engines. There are plugins that set particular headers, for plugins for authentication, plugins for marshalling and unmarshalling responses. The problem is that most of them are written by JetBrains themselves. And if that particular plugin doesn't exactly suit your needs, there aren't many examples how to create your own plugin. And that's what we needed to do. There were a couple of metrics plugins for Ktor, but those didn't suit our needs. We wanted to report the same metrics from our Ktor services as our Scala services, so we decided to build our own plugin instead. So today, I'll talk you through how to build your own monitoring plugin in about 20 minutes. I already prepared a project that starts a Ktor server and responds with some text. We'll see how we can implement a custom plugin to monitor this server. In order to do that, I also created a mock for our metrics client. If you ever worked with statsd, it's the same API, but instead of sending metrics somewhere, it will just print the results into the console. So let's start. So here is our server. Let's see that it starts. It will error 10% of the requests. So about each 10% will get an error. It's important to see in our metrics. And for all the others, it will just return some text. We'll start with installing a plugin. So let's go to our main model. And let's say that we want to install this plugin, which doesn't exist yet. Let's allow IntelliJ IDEA to generate that class for us. Okay, let's not. So once we created the class, Kotlin tells us that our plugin needs to have a companion object. This is basically a static factory method that we are going to implement. So let's allow IntelliJ to generate it. And my IntelliJ is misbehaving today. So let's do that ourselves. So that's a bit scary, but I'll walk you through what exactly that long signature means later on. First part is the part of the Ktor framework that our plugin operates on. So the plugin we will develop operates on the application level, on the request to our web framework. That's the first type. The second type is the configuration class the plugin receives. And the third type is our plugin. The reason we have this is that when plugins are registered, they are type safe, and I'll elaborate on that later. In the meantime, let's import this part. So that's the signature of our plugin. And let's just generate an empty class. And now IntelliJ will tell us that we need to generate two methods. So in order to create a plugin, we need to have a companion object. And that companion object needs to implement two methods. Let's start with the easier one, which is the key. So the key is just a way to identify the plugin. You can think about it like that. Ktor has a map of all those attributes, and each plugin adds itself to that map using that key. The string is not part of the key. It's basically just a description, just for debugging. The real value comes from the type. And as you can see, the type of the attribute key is the type of our plugin. That means that only the plugin itself can register as its type. It's a very smart way to have a type-safe registration. So unlike other frameworks where I would specify something like a string containing qualified path, here I just specify the type and basically compiler does all the work for us. So that's the implementation of the key. Now, let's move on and see how we can implement the install function. Install function is where all the interesting stuff happens. Before we start though, let's go back to our server and we'll pass the metrics client to our plugin. So if our plugin depends on another class, in this case, the client for metrics, we need to pass it to our client. So let's do that. Okay, so here we passing the metrics client to our plugin. And that's why we need the configuration class. So everything you want to pass to your plugin goes into the configuration class. That's the block that your plugin receives as the configuration. Now, in the install function, we need to get that client somehow. For that, we have that configuration block. As you can see, it's all typed. So this is the type, the second type that we provided, and that's the lambda that we receive. It's the lambda on the configuration block, and that's the class that we operate on. So here we got this block and we unwrap it. That's a common pattern in Ktor. So we copy everything that was passed to us, so our code will remain thread safe. The configuration itself is a mutable object, and that's why we need that. So we now passed the metrics client to our configuration block. It is now stored in this configuration class. And when the plugin is installed, we unwrap it and get the configuration. Let's continue and return the plugin itself. So that will allow our code to compile. And we are reading the configuration, but we don't do anything useful with it yet. But that's how you write not very useful Ktor plugin. Now, when we have this, before we start implementing the business logic, let's go back and discuss some more theory. Sorry. So we discussed the type of the plugin. So we have what the plugin operates on, how it's configured, and the type of the plugin itself. Now, before we can proceed, we need to discuss how a request lifecycle works in Ktor. So request in Ktor is represented by a pipeline. And in that pipeline, we have a setup phase where Ktor prepares the call. Then we have a hook for monitoring. Then all the parsing features kick in. And finally, we have the call phase. That's what happens for any request, a request that comes into our Ktor framework. And actually, there are two identical pipelines, one for requests and another for responses. So we go through one of them when we receive a request. Usually we transform bytes into some kind of an object. Then our business logic returns a result. And we need to transform that result into JSON or something else, and also set the correct headers. That's why we have two pipelines, one to process the request and another to process the response. In our plugin, since it's a monitoring plugin, we will focus specifically on the monitoring phase of the request pipeline. So we will implement our code in this part of the Ktor lifecycle. So let's go back to our code. To add logic to a certain phase of a request, we use a pipeline intercept. So here we intercept the monitoring phase. If we just want to continue to the next step in the pipeline and do nothing, we can use proceed function. It will be just like next function in some other frameworks, for example. And the nice thing about Ktor specifically is that you can write code that isn't necessary based on callbacks. It's basically an imperative code. So if the proceed call fails, we simply can wrap it in a try catch, and that's it. We don't need some kind of a error callback. So what we want to do now is we want to use our client and report whether we had a success, whether that call succeeded or whether it failed. So in order to do that, let's add a couple of new functions to our plugin. First, I extract it to a variable. That's pretty easy. So when the request fails, I want to invoke a function that is called a failure. And when the request succeeds, I'll invoke a function that's called success. Let's now implement those functions. So what do we do in the success phase? So for every request, if we didn't get any exception, we want to report that it was a success. In order to do that, I will use the client, the mock client I have here. So let's pass it. And if it was a success, then I want to use the method called increment success. And I'll use the URI just to see where the success was. If it was an error, then I'll use the same client. I'll just increment failure. And this one receives an exception, so we pass it here. Let's see again what we built. So our install method reads the metrics client from the configuration. It intercepts the monitoring phase for each request. It tries to run the request, allows it to proceed. If nothing bad happens, we report success using the client. If there was an exception, we report failure using the same client. Okay. Let's try and run it a couple of times to see what happens. I expect that at some point it should fail. Yeah, here it fails, here it fails again. Let's now see the logs. And as you can see, the plugin already works. So we have reports for failures, and we also have reports for successes. So we successfully managed to intercept all our requests and operate on them. This is nice, but we could do something more complicated and investigate how plugins work a little bit more. So on our client, on our metrics client, we have a third method that is called timer. And that will measure the time it takes for our request to succeed. So let's see how we can implement this as well. Let's add two more methods. One will be executed before each call, before we try to proceed, and one will be executed after. So for calculating the time of the request, what do we need to do? We need to remember the time the request came in, and when the response goes out, we need to fetch the time somehow and calculate the data and calculate the delta. And the delta will be the time it took us to process that request. So in order to store something for each request, we can use the attributes on the call. So here we have the request context, also known as the call. And on it, we have something called attributes. Attributes is kind of a map that has a key and a value. And now we'll discuss what the key is and what the value is. So let's start with the key. We need to somehow identify our piece of data, which is the time the request came in. So let's define it. And we need some type, so let's define that type as well. So this is the same pattern we used to register our plugin, but this time we use attribute key to register a metric for that plugin. The idea is the same. That allows us to register different features in a type-safe way. So this is the key. For every call, our plugin will store an object called metrics. Now we just need to have the value. So let's add it now. Let's make it a data class. So all the metrics you want to store about your request, such as IP, headers, and so on, you can store on the same object we created. For every incoming request, we will put currently one object in that map. Now, in the after part, no matter if our request succeeded or failed, we want to compute the delta and how much time it took us to process that request. So first, we want to fetch that value that we put here. We access the call again. On the call, we have the attributes map, and we specify the same key object we used to put the metrics and the metrics value, which is a really nice way of, otherwise you would have needed something like getting it as a string or something like that. But great thing about that is that this is type safe. So this already returns me a metrics object. And for other key, I can have a totally different object that will be stored in the same map. And it still will be type safe, and I still won't need to cast it. So it's super powerful design. So we have our metrics. We have what we stored in the before call. Now, all we need to do is to calculate the delta. So first, my after method needs another parameter. And this is called, I think, T. So what we do in the finally block is that for each request, we try to fetch the object we put in the before the call, and we calculate the delta between the values, between the current timestamp and the the timestamp we got from that map. Okay, let's see if that works. I'm looking to have some errors possibly. Yeah, there is one. And as you see, we also managed to capture the delta. So for each request, we first store one timestamp when the request comes in. Then we fetch that timestamp and calculate the delta to report the time it took for that request to be processed. The way I simulate that is that I just have here some random number between 0 to 10 milliseconds that I'm waiting. So yeah, this is all it takes to write a Ktor plugin. So once you understand the concepts, it's quite easy. It's just that you need to familiarize yourself with things like a request lifecycle in Ktor and the concepts of the attributes, which is a really powerful idea that allows us to write those plugins in a type-safe manner. So let me summarize what we achieved. We have created our own monitoring plugin that monitor Ktor's service, success rates, and also timings. When you create a new plugin, you need to decide on which pipeline you operate, whether you operate on requests or responses. And then you need to also decide on which phase in that pipeline you need to operate. Because, for example, if your plugin relies on the fact that some other plugin already transformed bytes into objects, then you need to intercept the call at a late stage, or vice versa. To implement a new plugin, you need a companion object that will be able to register the plugin. You need a configuration object that will receive all the external configuration, and all the logic is implemented in the install method. Let's see that again. So this is the minimum code you would need to implement a plugin. Some final notes. The code I showed you, both the final one and the initial one, are available on my GitHub. So if you're interested in that, it would be a good exercise where you start with the initial project that just starts a Ktor server, and you try to get to the final stage where you have a plugin that monitors that server somehow. If you would like to stay in touch, I have a Medium blog, I have Twitter, and also I'm an author of a Pragmatic System Design course that goes surprisingly well on Udemy. Last note, this is my book, please don't buy it. I'm working now on the second edition of that, and it should be published somewhere at the end of November. So I literally finished writing it a couple of or editing since it's a second edition just a couple of days ago. But I expect it to be published in the next month or two, and I hope it will be quite a good book for Kotlin lovers. That's it. Thank you so much.
Okay, thank you very much. There is one comment. I think it's about the book. It's a wow. Okay. So I do not see any questions right now, but maybe people will write something. And I have a couple of questions myself.
Sure.
We all seen last week, or it was 2 weeks ago, a presentation about new Ktor plugins, which are now going into the early access program. And I believe the aim of those new plugins to simplify. Could you please shortly describe what is the simplification? I believe it's a fewer number of those layers you need to implement.
So I didn't. I watched the presentation, but I didn't play with the new plugin system myself. My understanding from the presentation is just it's a DSL on top of the same logic. So basically, the life cycle stays the same, phases stay the same, but the DSL is simpler. And basically, instead of picking the phase and so on, you just tell whether you want to run it before or after or around something, and it will execute your code. So it will require less understanding of the inner workings, which is good because the inner workings, especially the attribute keys, are quite complex. And like Hadi said, it will simplify development of most plugins. I still believe that probably that part that I showed will stay relevant to understand how everything works under the hood.
Yeah, we will probably see when it's finally out and we can compare it. And the second question I have, you usually when you have some kind of plugins and when you have a lot of plugins, they start to interfere with each other. For example, I believe that those plugins, it's now called so formerly features, now they were
Features.
called plugins, now they're not called plugins. They could change the data propagating upstream and downstream.
Yep.
So, is there any kind of defense from the? I think when they introduce some kind of feature or plugin and it breaks working of other plugins.
I'm not familiar with that, and it definitely happens. Like the way currently the serialization and deserialization happens in Ktor is a plugin, so it literally transforms byte stream into an object and vice versa.
Yeah, because it's exactly the same. For example, in Gradle, when you have a lot of plugins, they start to interfere with each other, and you can't write that one plugin depends on the other plugin. Yeah, I believe it's the same in Ktor.
Yeah, it's the same. I think you can control the order they are registered because you are the one that registers them. But there is a more difficult API where you can say that you want to register your plugin before or after another plugin. I just want Intercept API is simpler, but you definitely can do that.
Yeah, I see. It's because we know a lot of examples where people try to do those plugins and they start to interfere, and you need some way a plugin to control plugins. And I believe that Ktor developers, maybe someone is still here, they need to keep this in mind.
Yeah.
Okay, thank you very much again, and I think the both talk and the recording will be useful for people trying to do that. And since there are no questions, I think we will finish for today. And as always, we will go to the Kotlin Moscow Telegram chat and continue the discussion in Russian. But of course, you can also ask questions in Russian, in English, but it's better to do here because it's a Russian-speaking chat. Okay, Alexey, thank you very much again for your talk. And we are stopping here.
Thank you.